Everyone, this will cover Chapter 19, Protecting Your Network. First concept that we're going to cover this week is the CIA triad. It consists of three main goals: confidentiality, integrity, and availability. That is the CIA triad. So let's cover each of those in a little more detail. Confidentiality just means that we're keeping unauthorized people from accessing, seeing, or reading, or I guess interacting with that system data in any way. Integrity means that we're making sure that the data is unaltered or manipulated outside of normal system processes. Availability, this means that the people we want to have access to that system or resources can access those systems and resources. If we keep something super secure in a way that no one can ever get to it, but then the people who need that information or need those resources can't really use those systems, doesn't really do us any good, does it? So the kind of big picture overall goals of IT security are to balance those three critical elements. There's something to keep in mind when implementing, reviewing, managing, or troubleshooting network system security. So we're going to talk a little bit about the zero trust model. The traditional network model, so not the zero trust model, but the traditional network security model was that you kind of implicitly trusted everything that was connected to the network, and you treated it as though all threats would come from outside the network. And so you try to protect your network from outside threats almost exclusively. The zero trust model, on the other hand, starts with a different assumption that almost anything can be a threat. And so you start with no implicit trust of any other devices inside the network or outside the network. I'm going to kind of scan through the NIST zero trust architecture definition right here. Zero trust is a cybersecurity paradigm focused on resource protection and the premise that trust is never granted implicitly, but must be continually evaluated. So that's kind of the sort of textbook definition of zero trust. But the short version is just to remember that whether it's inside or outside the network, you just don't trust anything implicitly or automatically. So in this model, we're not making the assumption that everyone connected is supposed to be connected. We're not making the assumption that every device is malware free. We're not making the assumption that every resource is accessible or should be accessible to everybody. For the zero trust architecture, all traffic a device encounters is treated as hostile, or at least not implicitly trusted. The advantage is this reduces the risk that attackers can use one compromised device to attack other systems. Defense in depth. This is a philosophy. So the idea here is that we acknowledge that you can't build a perfect, completely secure perimeter, and you should design security with a posture that assumes that every single defense can be beaten. So that is the idea, or the key idea behind this philosophy of defense in depth. Again, this is a philosophy. It's not a software program that you can buy or sort of antivirus, anti-malware software. Understanding what counts towards supporting the philosophy can be a little bit tricky, but these are some of the key things that you should focus on: network segmentation, enforcement, screen subnets, separation of duties, and network access control. Separation of duties. So the key idea here is we're trying to identify how people could abuse or misuse a system, determining what access they would need to do so, and splitting up that access so no individual can do it alone. So the idea here is we just don't want to let one individual or one group of individuals have too much power or control over a system. So we split that up and separate that, and we call that separation of duties. This is a summary of threats defined by CompTIA. I'm going to kind of quickly scan through them, and then we'll go over some of them in a little more detail. So we have spoofing, packet protocol abuse, zero-day attacks, rogue devices, ARP or ARP cache poisoning, denial of service, and some of the variations, on-path attack, also called man-in-the-middle attack, session hijacking, password attacks, compromised systems, insider threats, VLAN hopping, administrative access control, malware, social engineering, and some more things. We'll cover each of these in a little more detail, or most of them anyway. Threat terminology. Vulnerabilities. Weaknesses a threat takes advantage of to work. Exploit. An actual procedure for taking advantage of a vulnerability. Attack. When someone tries to compromise your organization or its system. Spoofing is essentially when an attacker pretends to be someone or something that they aren't. Any data sent on a network can be spoofed. So here are some examples of commonly spoofed data. Would be something like a source MAC address or an IP address, ARP messages, email addresses, or web addresses. DNS cache poisoning. This type of attack targets a DNS server, and it will cause the DNS server to redirect targeted users to a malicious website rather than the intended website. Prevention of DNS cache poisoning heavily depends on this right here, DNSSEC or DNSSEC. All DNS root and top-level domains use this feature. Protocol abuse is essentially where we are creating a threat by misusing a protocol, using a protocol in a way that it wasn't really designed to be used for some malicious purpose. Zero-day attacks essentially leverage previously unknown vulnerabilities. So it's essentially the type of attack that people have had 0 days to fix, prepare, or mitigate. They're kind of vulnerabilities that people are unaware of. Rogue devices attempt to usurp trust power. The idea is they're trying to trick a client into believing that the rogue device is a legitimate, authorized device. How do we defend against this? Well, one strategy is called DHCP snooping. And this is the idea here is we have a database of known DHCP servers and client MAC addresses. And then what we do is block connections to untrusted ports. So we stop all unauthorized DHCP traffic. That DHCP snooping thing that we just talked about, it does a great job working for IPv4 networks, but not IPv6 networks. For IPv6 networks, we use RA-Guard. We use RA-Guard for IPv6 networks. Works almost the same way. It enables a switch to block router advertisements and router redirect messages from untrusted ports. Before we jump into ARP cache poisoning, let's do a quick recap on ARP tables and the address resolution protocol in general. So every device on or every node on a network will have an ARP table, and we use this in conjunction with the address resolution protocol to help resolve which IP address goes to which MAC address and which MAC address belongs to which IP address. One of the problems is that if the sending device doesn't know the address of a destination, it will send out a special broadcast called an ARP request. One of the problems with that is there's no inherent security built into that system, and it will kind of trust whatever it's told. I think we can easily see how this can lead to a few problems. If a bad actor gets inside a network, they can send out false ARP frames, and since other devices will just kind of take it at face value, they will add that information to their ARP tables, and now they have incorrect address information on their ARP tables. Once an attacker successfully poisons the ARP table, they can carry out a number of attacks. They can do things like an on-path attack or a man-in-the-middle attack. Okay, this graphic here will kind of help us visualize what we're talking about. We have some number of devices on a network, and essentially what our attacker will do is it will try to manipulate some of the other devices to convince them that our attacker here is actually the gateway. And so instead of the client sending its information directly out to the internet, what it will do is send all its information to the attacker first. Then the attacker will usually intercept. Maybe they will read or manipulate that data in some way, and then they will send it out to the internet. They will, again, receive the information as it comes back. So they will just kind of serve as a man in the middle, hence the name man in the middle attack. So how do we defend against that type of attack? Well, we use something called a DAI capable switch. This stands for Dynamic ARP Inspection. DAI stands for Dynamic ARP Inspection. And this technology relies on ARP information from DHCP snooping that we just talked about a little bit ago, and that will be stored in a DHCP snooping binding database. Essentially, the kind of short version here is it will try to build a database of good IPs and MAC addresses or good devices and unknown devices. And if a unknown device pretends to be the gateway, what it will do is recognize that, hey, you're not on my list, and it will block that device. This one's a little more common, so most people have probably heard of it already, but we'll cover it anyway. Denial of service, also known as a DOS attack. It is a targeted attack, usually on servers. The goal is to prevent the server or servers from processing incoming server requests. There's many forms of DOS attacks. One that most people don't think of is it can be a physical attack. So if someone powers down the servers or in some way vandalizes and attacks the servers physically, that would also count as a denial of service attack. Usually it is something like flooding a target computer or a target server with requests or some type of thing to kind of overwhelm the server or the computer so that it is unable to process normal services. There is another form of a denial of service attack called a distributed denial of service attack, usually referred to as a DDoS attack. The idea here is that rather than using one computer or one device to target a server, you have many computers or many devices targeting a server. Usually it's not people who are intentionally participating in it. So I think the example that the book talks about is it's not like an attacker and a million of his friends or thousands of his friends are all sort of working together to target a bank or some type of server or service. Usually it's one bad guy who has infected a number of devices with some kind of malware, and he's using this as a zombie botnet or some kind of botnet to target a group of servers or some kind of service. As might be expected, a DDoS attack is usually much more effective than a standard DOS attack. If you're trying to overwhelm a server or overwhelm some sort of device, it is easier to do it with many devices. This is a graphic that's going to help us kind of picture a DDoS attack in combination with what is called a reflection and amplification attack. So the idea here is we have our attacker and his botnet or his or her botnet. So many devices under his or her control. And what they will do is send out some kind of request to other devices, usually some kind of server. And the idea is they'll send out a request that takes very little information to create that or generate that request, but it generates a tremendous amount of information in return. So it's sort of asking a simple question with a very long answer. And instead of receiving that information back, what they will do is pretend to be another device. So all of these devices, this whole botnet, this whole collection of could be tens, hundreds, thousands of different devices are all pretending to be the victim's computer. And what they'll do is send out this sort of request to many different devices or many different servers, and all of them will flood that message back at that one intended target, and that will usually overwhelm that target, usually causing a server to crash or maybe potentially just being so slow that it can't carry on its normal service, essentially denying the service that it would normally provide. Deauthentication attack is another type of attack that people will encounter. The idea here is you're trying to forcibly get someone deauthenticated or kind of kicked off a network temporarily. Sometimes the goal can just be to be disruptive and obnoxious. However, usually it is accompanied with more steps in the process. So you may get someone kicked off a network, and then when they go to rejoin the network, you have a rogue, or the attacker will have a rogue wireless access point that's set up. And so when the attacker goes to reconnect, they unintentionally or accidentally connect to the rogue access point rather than the intended good access point that they were going for. Attackers will usually target a specific Wi-Fi frame. This is called the deauthentication frame. Attackers use a good disconnect frame for an evil purpose. DHCP starvation attack. The idea here is that a DHCP server only has a certain number of addresses to lend out. So what an attacker will do is attempt to trick the DHCP server into giving all of its addresses away. And then usually that will be followed up by the attacker using a rogue DHCP server. On-path attack. So this is essentially the same thing as a man-in-the-middle attack. So it's just two names for the same type of attack. And we covered it a little bit earlier, but again, this is just a recap on it. We have our different devices on a network, and the attacker will essentially insert themselves in the middle of the gateway and the clients on the network that will pretend to be the gateway. And again, the classic form of the attack is to spoof the SSID. The attacker can gather passwords, shared keys, and other sensitive information. Session hijacking is a little bit different than a man-in-the-middle attack. Here, the attacker is trying to intercept a valid computer session to get authentication information. They're not listening in the same way they would with a man-in-the-middle attack. They're primarily just trying to get authentication information. There are many different methods of password attacks, but often when we're talking about a password attack, we're talking about comparing various potential passwords against known hashes of passwords. There's a few key methods that we're going to talk about: the brute force method and the dictionary attack method. Brute force, this term isn't exclusive to password cracking, but you'll usually hear it in that context. The idea here is that the target is using some sort of program to try to guess every combination or permutation of something to try to guess a password. So they'll literally go through and guess 1, 2, 3, 4, 5, A, B, C, all that, every single combination of word to try to guess a password. And that is the brute force method, usually carried out through some sort of script or program to carry out that attack. The dictionary attack is somewhat similar, but rather than randomly guessing every combination of letter and number, it will usually use predefined sort of dictionary words to try to predict what all the passwords are. And it can usually make the cracking process much quicker and much faster. One thing to note, it doesn't, even though it's called a dictionary attack, it doesn't have to be, it's not a game of Scrabble. It doesn't have to be a official dictionary word. They can use substitution or any combination of things like that with exclamation marks, question marks, at symbols, all that kind of stuff to make substituted words. Insider threats are another major consideration. So you could have something like a malicious employee that is inside your network, has some level of access, and is intending on harming your network. So they have easy access to data. They may inject malware or initiate attacks inside your network. You have different levels of privilege that you have to be concerned about. So you have a trusted user. This is someone with administrative powers. You have an untrusted user. This is a user who has no administrative powers granted to them. Oftentimes, when we think of an insider threat, we're thinking of a malicious employee, someone who is intentionally trying to do harm to the network. But it's worth noting that it can also be someone who is unintentionally participating or causing some kind of harm to the network. Maybe an employee didn't notice an email was a phishing attack. They downloaded some sort of malware or something like that, and that caused some sort of damage to your network. That would also be an example of an insider threat. Malicious users. We talked about this one a little bit before, but we're going to go ahead and cover it again real quick. This is someone who is consciously attempting to access, steal, or damage resources. Malicious actors will use tactics like packet sniffing, trying to identify open ports, grabbing banners, or collecting organizationally unique identifiers, OUIs. VLAN hopping. We talked about this in a previous chapter, but again, it's kind of an older form of attack. The idea is that they are trying to use some sort of command or method of abuse to hop from one VLAN to another one. So maybe they're supposed to have access to one VLAN, but they use some sort of exploit to hop to a different VLAN that is supposed to be restricted to that user. One important consideration is what we do with unused components and devices. So every computing device and IT system has some kind of life cycle or lifespan. We need to decide what we do with them when they're no longer needed or obsolete, and how we dispose of them properly to protect our information and the integrity of our network. Malware is essentially any program or code designed to do something on a system or network that you don't want to occur. Examples of malware could be these types of things: virus, worm, Trojan horses, macros, rootkits, and adware and spyware would be good examples. Crypto malware and ransomware. This is a particularly vicious attack, and it was fairly popular not too long ago. The idea here is they're using some form of encryption to lock a user out of a system, or usually encrypt all their data so that a user will no longer have access to that information or their devices. This can be especially damaging for things like research institutes, schools, hospitals, or those kind of organizations. Usually it's accompanied by some sort of ransom. That's where it gets the name ransomware, is once the data is encrypted or secured, they'll usually try to get the user to pay some sort of fee or ransom in order for the attacker to unlock or give them access back to their network or their devices. Virus. This is a program designed to replicate and to activate. Replication just means that it's making some kind of copy of itself. Viruses can only replicate to other drives. They can't replicate across networks. Activation. This just means the action that is taken by the virus. So again, one of the examples could be erasing boot sectors or some kind of erasing some information off a drive. There are a lot of possibilities. So a virus can do a number of things, but that's just one example. Viruses require human interaction to spread. A worm functions very similar to a virus, but replicates exclusively through networks. A worm sends copies of itself to other computers on a network, can exploit inherent flaws in a program code, and unlike viruses, worms do not need host files to infect. Macros. This is a type of virus that exploits application macros. So this is something that you might encounter when working with something like Microsoft Excel. Logic bomb. This is code that is written to execute when certain conditions are met. So usually with malicious intent. The kind of go-to example is maybe An employee sets a logic bomb so that if the employee is ever fired, the logic bomb will go off and create some kind of havoc or do some sort of damage to the company network or systems, databases, or something like that. Trojan horse. This is a piece of malware that will pretend to do one thing while simultaneously doing another. It may actually do the thing that it claims to do or intends to do. So it could be something like a game or a free screensaver or some type of program or application that you may find useful. And but the downside is it comes with the Trojan horse, the malware embedded in that program that will cause some sort of harm to your computer. One thing it may do is something like a keylogger, which will record keystrokes or any number of other things. Rootkit. This is malware that uses low-level operating system functions to hide itself. These can be particularly nasty and very hard to get rid of. Adware and spyware. Adware monitors website history and uses information to generate targeted ads. So you usually get like lots of pop-up windows or different things like that with adware. Spyware will usually kind of secretly collect and send information about your system or your network or your actions to something else over the internet. Social engineering. So while many of the other attacks that we have talked about will target your computer system, social engineering targets people. The idea here is they're trying to manipulate people or individuals in an organization to gain access to a network. There's a ton of different social engineering attacks. Usually they'll involve some sort of telephone scam, physical entry, or phishing. A phishing attack is usually an attempt to gain a user's confidential information. The attacker will pose as a trusted site or source. So on the right here, we have an example of kind of the go-to common phishing attack, someone pretending to be your bank. We'll say there's some kind of emergency with your account. They'll include a link. You'll click the link and it will be a fake site or fake bank or download some kind of malware or something like that. Usually the goal is to get you to click on a link and download some sort of malware or go to a site where you input your credentials or other information that the attacker can use to their advantage. Shoulder surfing is a fairly simple concept, but it's surprisingly effective. The idea is just looking over someone's shoulder. So as they're inputting a PIN number into a card reader at the grocery store, as they're entering their username and password, that kind of idea, or collecting information by simply looking at their screen while they're conducting some kind of business. So pretty effective tactic. Physical intrusion is another thing you have to be careful with. If an attacker can gain access to your network or your routers or your switches, there is a good chance they can do a lot of damage. So you want to make sure your servers, your networking equipment, make sure all of that stuff is secured. There are a few more key topics in this chapter that are worth looking at: common vulnerabilities, hardening your network, and firewalls.